In this session, we are going to define grammar. Now, what is a grammar? A phrase structure grammar or simply a grammar is expressed with the help of four tuple. So, they are Vn, sigma, Ps. So, Vn stands for set of non-terminals. Okay. What is a Vn? Vn is a finite non-empty set whose elements are variables, also known as non-terminals. In our grammar, mostly we use capital letters to denote this particular Vn elements or variables or non-terminals. Here sigma, but in some other cases you might be finding that it is not sigma, it has been mentioned as Vt, that is set of terminal symbols. So, sigma or Vt is a finite non-empty set whose elements are terminals. Normally, in our grammar representation, we represent terminals using lowercase letters. Vn intersection sigma is equal to phi. That means, you cannot find a single grammar element or grammar symbol which is non-terminal as well as terminal at the same time. So, that is why Vn intersection sigma is equal to phi. S is a start symbol where S belongs to Vn. So, S is the start symbol, that is a special kind of symbol. Symbol means non-terminal, a special kind of non-terminal, that is a start symbol, and here it is S belongs to Vn. As I told you, it is a non-terminal. P is a finite set whose elements are alpha produces beta. So, here we are having this P. So, P is a finite set whose elements are alpha produces beta, known as production rules or productions or rewriting rules, where alpha and beta belongs to Vn union sigma whole star. That means, alpha and beta should contain some elements from Vn and Vn union sigma. That means, terminals and non-terminals will be there in alpha and beta representation, but alpha should contain at least one symbol from Vn. So, the left hand side, that is alpha, should contain at least one symbol from Vn, that is set of non-terminals, so or variables, whatever it is, and beta is having no such constraint. That means, any symbol from terminals and non-terminals may participate in beta. So, that is my production rules or productions or rewriting rules. Now, let us go for one example. So, let us suppose we are having one grammar, that is Vn sigma Ps, and here Vn is having sentence, noun, article, adjective, verb and article. So, these are the, I have written the article twice, okay, I am erasing this one. Okay. So, now we are having this sentence, noun, adjective, verb and article. And sigma, we are having Ram, Rita, Ajad, is, are, a, and, good, bad, boy, girl. Here, according to this notation, I have enclosed non-terminals or variables within angular brackets, and sigma, they are not enclosed within angular brackets, only to have the differentiation. And S is the sentence and there is the start symbol. So, now here we are having this set of production rules. So, P consists of the following production rules. So, that is sentence produces noun, verb, article, adjective, noun. Just look here, you see this is my alpha and this is my beta. So, alpha produces beta. Here you see alpha and beta, they are belonging to Vn union sigma whole star. Because why whole star? Because you see noun has come twice. So, it is a multiple combination of these symbols. Okay. Another thing is that here this alpha is containing at least one symbol from Vn. Okay. Now, see, noun can produce Ram, Rita, Ajad, boy, girl. Verb can produce is, are. Article can produce a, and adjective can produce good or bad. So, in this way you have written. Now, what is this? Actually, it is nothing but adjective can produce good, adjective can produce bad. So, I could have written two production rules against this, but that is a common notation putting that pipe sign, that is the or. Adjective can produce good or adjective can produce bad, and that is the notation in which we have written two productions in this way. Okay, now, so this is my grammar given. So VN we know, VT we know, P we know, and S we know. Now let us suppose there is one sentence has been given, is that say Ram is a good boy. I am just writing that one. So I am writing that one as so that is the sentence where I am having. Now see, I am having one production known as noun can produce Ram. So noun can produce Ram. So I am just making this one. You see, verb can produce is, article can produce a, adjective can produce good, and noun can produce boy. So I am writing this one in this way. See. So noun, verb, article, adjective, noun. So now we are having one production rule. Sentence can produce noun, verb, article, adjective, noun. So I can write this one. So what is happening? From the start symbol, you can reach to this particular Ram is a good boy. So this sort of tree is known as parse tree. So this is my grammar, this is my parse tree, and this is my sentence. This is a sentence. So that is Ram is a good boy is a sentence. So in this way, we can check whether a particular sentence can be derived by a given grammar or not. So that is the one kind of testing we will be doing in this particular grammar chapter. So how to define a grammar? There is a theory portion I have discussed with an example how to define one grammar and what is the parse tree and how does a sentence can be parsed by this parse tree construction, and from this leaf nodes or terminal symbols. So that's why also it is known as terminals. So why it is called terminals? Because they will be found as the leaf nodes or terminals of this particular parse tree. So that's why they will be known as the terminals. And if this parse tree construction from this terminals to the start symbol or from the start symbol to the terminals can be done successfully, that means this particular sentence is in accordance with this particular grammar given. So I think you are getting this logic. On this particular topic we are going to have other videos. Please watch them, and thanks for watching this one.